Before we get going too far, please turn to the next page of the document. In there, you'll see two data tables. Label the top data table for the Brown spring. And the left-hand side column, we have a delta X, which we're going to use for the stretch or change of position of the spring. Notice that that's measured in meters. The second column is force. We'll use a capital F for force, and that's of course measured in newtons. Now, take a look at the left-hand column. The starting stretch will be 0. That's when the spring's not stretched at all, and that of course takes 0 newtons of force. But we're going to compress this, we're going to stretch the spring 1 centimeter, which is 0.01 meters, 2 centimeters, 3 centimeters, 4 centimeters, and 5 centimeters. But it's important that when you scale your graph, that those are 0.01 meters up to 0.05 meters when you make your graph. We'll have to see how big we're going to make the forces for that. Next up, as I told you, we'd open up a LoggerPro file. This is a brand new file. I just opened it, haven't done anything. Notice in the lower left-hand corner here, we have a little text box. I'm gonna go ahead and grab that corner and pull that up there. Now, right now we have a force probe and the spring, and it's not really stretching it at all. So we're gonna make this 0. So we're going to go up to the 0 button and hit that, and our force should turn to about 0. So now we're going to go ahead and stretch the spring up to the 1 centimeter mark. Oh, so just so you can see from the top, you got 0 centimeters. I'm going to stretch it to 1 centimeter. Notice it's the end of the last rung is what I'm looking at, not the hoop at the bottom. And for 1 centimeter, you've got 0.26 newtons. And then 2 centimeters, 0.49 newtons. 3 centimeters, 0.74 newtons. 4 centimeters, 1.04 newtons. And 5 centimeters of stretch, 1.3 newtons. But wait, there's more. In addition to this brown spring I have here, I have this other spring that's lighter in color. We're going to call this the silver spring. We're going to go ahead and attach that on there. And notice that the 0 spot on there is at the same 0 spot as it was for the brown spring. And we're going to go ahead and stretch it 1 centimeter. Go to your second data table and record these as the silver spring. To stretch it 1 centimeter or 0.01 meters, it took 0.8 newtons. To stretch it 2 centimeters, 1.5 newtons. Wow, that's way more already. 3 centimeters, we get 2.42 newtons. 4 centimeters, we're at 3.27 newtons. And 5 centimeters, we're at 4.35 newtons. Remember, if you missed any of those data points, you could go back and play the video again or pause between each one. So at this time, you're going to go ahead and make a graph for force versus stretch. Remember to scale your axes appropriately. The biggest stretch anybody will need is 0.05 meters, and the biggest force anybody would need is whatever that biggest force was from that silver spring. I think it was around 3.5. I think that's what it was around. So 3.5 or 4. So that's what you're going to have to scale the x-axis by. Anyway, good luck with making your graph and plot those points. If it's a curved line, you're going to want to think about how do you linearize it. If it is a straight line, then you want to find the slope of that graph, and we'll look into mathematical analysis tomorrow. Thanks.